Hi, in this video we will solve the nonlinear rational inequality 9 plus x over x minus 7 is greater than or equal to 0. The first step is to take the numerator, the top of the fraction, and equal it to 0. Also, we will take the denominator, the bottom of the fraction, and equal that to 0. We are now going to solve both of these equations. Subtract 9 from both sides to get x equals negative 9. Add 7 to both sides to get x equals 7. We are going to put those two numbers on a number line, making sure that you put them in order from smallest to largest. Note that these two numbers divide your number line into three separate regions: a left region, a middle region, and a right region. From each region, we are going to pick a test point. So, pick any number that is less than negative 9. It does not matter which number you pick as long as it is less than negative 9. I'm going to say let's pick x equals negative 10 as your test point for the left region. To find a test point for the middle region, we are going to pick any number, it doesn't matter which number, between negative 9 and 7. Since 0 is between negative 9 and 7, let's test x equals 0 for the middle region. And for the right region, we are going to pick any number bigger than 7 to test. Let's pick 10 because 10 is a nice, easy number that's bigger than 7. To test these points, we are going to substitute each of these values into the original inequality. So, to test x equals negative 10 in the original inequality, we are going to put a negative 10 wherever the x was. The numerator is 9 plus negative 10. The denominator is negative 10 minus 7. If we simplify this, we end up with negative 1 divided by negative 17. A negative divided by a negative is a positive, and we're wondering, is 1/17 greater than or equal to 0? Yes, positive 1/17 is greater than or equal to 0. This statement is true. Since x equals negative 10 was from your left region, and we ended up with a true statement, that means we will label your left region as being true. Now let's test x equals 0 in the middle region. Just like before, substitute 0 for the x in your original inequality. So put a 0 in for both x's and see what you end up with. After simplifying, you will end up with 9 divided by negative 7. We're wondering, is that greater than or equal to 0? Well, a positive 9 divided by a negative 7 is a negative number. A negative number is not greater than or equal to 0. This is a false statement. Since x equals 0 was from your middle region and we ended up with false, that means we will label the middle region as false. Now let's test x equals 10. I know this gets a little bit tedious, but I also suppose tedious is better than hard. Put a 10 wherever the x was, and simplify to get 19 thirds, and determine whether that is greater than or equal to 0 or not. Well, 19 thirds is positive, and a positive number is greater than or equal to 0. This statement is true. Since x equals 10 was from your right region, and we ended up with a true statement, we are going to label your right region as true. At this point, we're going to shade everywhere that you ended up with true. So since your left region was true, we are going to shade this entire left region. Also, since the right region ended up as true, we're going to shade the entire right region. We still have a little bit more testing to do. We actually need to test your endpoints. So we need to test x equals negative 9 and test x equals 7 in the original inequality. So to test x equals negative 9, put a negative 9 where the x was in the original problem. And see what you end up with. A 9 plus a negative 9 is 0, divided by a negative 9 minus 7 is negative 16. 0 divided by negative 16 is 0. Question, is 0 greater than or equal to 0? Well, yes, 0 does equal 0. This statement is true. If you are testing an endpoint and you end up with a true statement, that means to use a bracket on that endpoint. Since negative 9 ended up with a true test, we are going to put a bracket on the negative 9 with the ends of the brackets pointing towards the shaded region. Now let's test the other endpoint of x equals 7. Put a 7 in for both x's in the original inequality and simplify. You will end up with 16 divided by 0. However, can you divide by 0? No, you cannot divide by 0. 16 divided by 0 is undefined. If it is undefined, it's not bigger than or equal to 0. It's false. You can't divide by 0. Dividing by 0 is bad. And if you test an endpoint and end up with a false statement, that means to use a parenthesis on that endpoint. So we are going to put a parenthesis on the x equals 7 endpoint. Again, with the points of, or the ends of the parentheses pointing towards the shaded region. We are very close to writing your answer. For this first region, it is shaded forever to the left. In other words, it is shaded all the way to negative infinity. So the shaded region starts at negative infinity. We're going to put a comma, and then this first shaded region ends at negative 9. Infinities always have parentheses when you use interval notation. This negative 9 was true when we tested it, so it gets a bracket. And since we have this gap in between the shaded regions, we are going to use a union sign in interval notation. Now we write this second interval. 7 is where the shaded region starts. 7 has a parenthesis. Write a comma. And this second shaded region is shaded forever until you get to infinity. Infinities always have parentheses, they kind of rhyme. And there you have it. That is your solution to the nonlinear rational inequality of 9 plus x over x minus 7 is greater than or equal to 0. In other words, any number within either of these intervals will make the original inequality true. That's all I have for today. Thanks for watching.